All right, let's get started. So two things that I want to talk about. One is bearing. So in this section, we'll be given some angles in terms of bearing angles. We're going to measure bearing in two ways. The first is mostly for surveying and sea navigation. And the way the bearing is given, yes, surveying.
Sorry. Thank you.
For surveying and for sea navigation, bearing is always an acute angle.
You're a cute angle.
From the north-south line. And the notation is a little strange. So for example, it might say north 56 degrees west. The way I think about this one is 56 degrees west of north. So if we were to draw this, if we draw our little compass, there's north, east, southwest. So 56 degrees west of north would be this angle here. If we had an angle of south 37 degrees east, I think 37 degrees east of south. So that one, if we drew our little compass, .37 degrees east of south would be here. So that's the angle that this bearing would talk about. So you don't have to label it, but they'll give you a problem and they'll say the bearing of such and such from such and such is this. You'll just need to be able to translate that into the angles that you need to find in the problem. Okay. All right, so that's the first way that bearing is, angles are measured in terms of bearing. The second way, for air navigation. For air navigation, bearing is measured from due north. So if the bearing is 192 degrees, if we had a bearing of 192 degrees, what they're talking about there is, if this is north, it would be this angle. I'm just going to write my other, something like that. It's measured clockwise from due north. So that would be a bearing of 192 degrees. So a bearing of 180 degrees is due south, 270 degrees is due west, 90 degrees is due east. So those are, so you'll be given problems, a few problems that measure the angle in terms of bearing, and you just need to be able to translate that into what you need to find for your problem. The other thing to remember in terms of bearing is when you have parallel lines. For example, if you draw your north-south line in two different places on your diagram, So I'm going to say these are parallel. And we cut the parallel lines by some other line, maybe the sides of a triangle that you're trying to work with. When that happens, these alternate interior angles are congruent. So sometimes you'll need to figure out your bearing at one location, at another location, and you need to take advantage of this fact with the congruent angles there when you translate your little compass heading to your different places. All right. So just the bearing just gives another way to give you interesting problems to solve with trigonometry. All right, the next thing that I want to show you is using your calculator to model a trigonometric function. So we had a homework problem back when we were graphing sines and cosines, and I said, if you didn't remember how to do it, don't worry about it then. I will show you how to do it later. Later is now. All right. So the first thing that we need to do is get our data into the calculator. I'm going to do this, zoom, 6, clear that, clear. This is in a different mode from a different thing that I was doing. All right, so we need to get the data into the calculator. So I had mine, there was a bunch of, I had this setting from the end of last year. We need to get our data into the calculator. So we're going to go to the Stat menu. So press the Stat button. And we're going to edit. So I just hit Enter.
We're doing this thing.
And I'm going to enter my X values in L1 and my Y values in L2. So you arrow up to L1 and then hit clear and then arrow back down. So in your book on page 301 we were assigned problem number 87 where it talks about the day of the year and the percent of the moon that's illuminated. So I'm going to enter the data from that problem. So my X values are 23, 31, 38. So these are the days of the year. So where January 1st is day 1, 38, 45, 52, and 61. And the Y values, go back up. Over here, and this is a percent that the moon is percent of the moon that's illuminated. 0, so that's a new moon. 0.5, half moon. 1 is a full moon. 0.5 again. So it's going the other direction. 0, and then we go back to 0.5. So those are my Y. That's my Y data. And we want to plot that data. So to plot the data, I'm going to go to stat plot, so second y equals. And I need to turn one of these on. I'm going to hit enter and turn that on. And it says our x's are coming from L1, our y's are coming from L2, our mark is going to be this little square. So my plot is on, yes. To the what? The numbers? All right, so then we go to second stat plot. Turn plot number 1 on. So I just hit enter. This is on. And then we're going to go back to our stat menu. And we're going to calculate. Oh, no, I want to plot these first. So let's graph. Graph. Well, I don't see anything. That's because my x values go from 23 to 61, and my y values go from 0 to 0.5. So I'm going to set my window. So I'm going to set this at 20, and I'm going to do this at 65, and I'm going to do the y from 0 to 2. And now I'm going to graph that. So there's my data. So it kind of looks like a nice curve would model that data. So let's come up with a model for that data. Now I'm going to go back to my stat, and I'm going to calculate. And under the calculate, it gives you all kinds of options. This median line, linear regression, quadratic regression, cubic regression, quartic regression. So I'm going to keep going down. I have a different linear regression, a logarithmic regression, exponential regression, a power regression, a logistic regression. Finally, a sign regression. So I'm going to hit enter when I get to my sign regression. And this just is some stuff that tells the calculator how it's going to do that. Depending on the model, you won't see this. And I don't use the calculator enough to remember how to store the regression equation, so I'm just going to calculate it. All right. So the calculator tells me that my model is y equals a sine bx plus c plus d. And I'm going to write these numbers down. So a is 0.49, b is 0.21, c is 0.11, and d is 0.47. And now I'm going to graph that equation on top of the data that we've already plotted. So I'm going to go to my y equals, and I have 0.49 sine 0.21 x plus 0.11. Close off the parentheses. Whoops. 0.111. That's okay. Plus 0.47. And I'm going to graph that. And there is the model for that data. And it's pretty good. It's pretty close there. And now if the question asked us on the 75th day of the year, out here somewhere, what % of the moon is illuminated? You could look at your Y value. If it said between what dates is the moon more than 50% illuminated? So you find the X value here and X value here, and that would tell you when the moon is more than 50% illuminated. So you could do solve some various kinds of problems with this model for our data. All right, questions? So 0.49 sine 0.21 x plus 0.11. I accidentally entered a couple of extra ones. Plus 0.47. Yeah, make sure you're in radian mode when you're graphing trig stuff. What? Go back where? And what you're going to want to do now before you graph something else is, so those little data points don't show up on all your graphs, you're going to go back to your stat plot and turn this off so you don't plot those points anymore. And then you might want to do your window or zoom, do zoom standard, so your window is centered on 0, 0 again. So this would be that, just the very beginning part of that sine curve. And it only goes up between 0 and 1. So we're just getting a really small part of it there. And I'll clear that out. Clear. All right. That's all I wanted to talk about today. There we go.